Good morning, Internet. My name is Jack C. Are you looking for a quick and easy way to improve your speech recognition AI models? Well, I got something here just for you. A few months ago, Meta AI released a paper that proposed a new training procedure that can boost your speech recognition model accuracy by about 7 to 9%. It is called the Adaptive Multi-Corpora Language Model Training. Let's dive into it. Automatic speech recognition, or ASR, is a technology that focuses on converting spoken language into written text, and it uses machine learning. The current state-of-the-art ASR models uses an acoustic model to generate probability distributions over vocabulary characters per each time step. And yes, you could use a simple greedy decoder to by selecting the highest probability characters for your output. But what you want instead is to use a large language model as part of the decoder, and it helps to improve the accuracy of the acoustic model prediction thanks to its underlying language understanding. Typically, the large language model can be trained separately from the ASR models. Since we only need text data to train the language model, improving ASR models can be simply achieved by improving the language model, especially when there is a mismatch between the source and the target domains. However, the performance of a large language model highly depends on the quality and the quantity of the training data in any adaptation task, which is bad considering that usually the target domain does not have any adaptation data. So we have to resort to text data from multiple corpuses. Some corpuses may belong to a similar domain with the target, while some may not be. So the question is there a way to improve the performance of a large language model by leveraging large-scale multi-corpuses in a smart way? A standard approach would be to train an n-gram model on each of the corpuses and interpolate them to create the final model. This sort of interpolation gets really difficult once we start to use large language models, as they are non-linear. So instead of interpolation, we can try to mix and sample the data from the different corpuses. A naive approach would be to sample each corpus according to a static predefined probability distribution. Recent studies show that the order of feeding corpuses into the training process is important for boosting the model performance. And this indicates to us that the sampling probability of each corpus should be adjusted dynamically. And this is what Meta AI did exactly. They attempted to create a method that adaptively optimized the sampling probability per corpus during the training process. Higher probabilities are assigned to the specific corpus that will likely play more important roles towards improving the performance on target domains in certain training epochs. In those scenarios where the order of feeding corpuses into the training process is important, this algorithm will automatically choose their relative orders by assigning higher sampling probability to a corpus when its turn is coming. And here is how they did it. We start off with initializing the language model parameters, and we create k copies of the model. Then we fine tune each model with each different corpus for some number of iterations. After that, we perform an interpolation weight optimization operation on all language models, which helps us to create a mixed corpus that we want. Then we feed that mixed corpus into the main ASR training procedure for just a single epoch to get the prediction error. Overall, the entire process is differentiable. And with that, we get significant improvements over using static sampling probability distribution methods and the use of n-gram models in both in-domain and out-of-domain speech recognition tasks. And that's it. Thanks for watching, and don't forget to like, comment, and subscribe, and I will catch you all in the next one. Cheers.